Please welcome Intel's CEO, Pat Gelsinger.
Welcome all. Good morning, good evening. Shana Tova to all of our friends who are celebrating Rosh Hashanah, and our Israeli talent just play a huge role for Intel, and Mobileye and our teams there spending the holiday with their family and friends. But to the rest of Team Intel, we are here and we're going to have a great event together now. And it's wonderful to be back, what do you think, in person? Yeah! In person, in our backyard here in Silicon Valley. And a beautiful day today, so let's get started. And as the host of Innovation 2022, I have to affirm Intel's deep, unwavering commitment to an open ecosystem. And last year we said we'd innovate on future technologies in the open. We would offer you choice. We'd help drive industry-shaping standards. And, as we said, we have to make them more secure. These platforms have to be things that you can trust in and build your platforms and businesses upon. And over the next 2 days, we're going to show you our progress, but also look into the future in these areas as well. And we have a ton of news for you today in hardware, software, chip design, security, new developer platforms, and everything the industry has to offer. We're going to geek out. Did you get it? Right? Okay, all you geeks in the room, if you don't get it, right, go back and check your ASCII coding again, right? This is geek in ASCII, right? So, and we're gonna have some expected guests, but some unexpected guests as well. And we're gonna have a great show for you this week. You can think about this as a keynote in 2 parts, right? You got me today, and you got Greg Lavender, our CTO tomorrow, talking about many of our software-first and developer-focused activities. And for those here on site, join us in our innovation zone where we're going to have some geeky demonstrations, get to look firsthand. And for those of you online, wish you were here, but the online experience is going to be great. Stay on afterward for expanded coverage, and you don't want to miss it. So let's get started. We're in this new era, and it may not be quite post-pandemic, but we're starting to see our way to the other side of it. And through this period of time, we have seen the increasingly critical role that technology plays in every aspect of human existence. Everything is going digital. How we work, how we learn, how we rest, how we care for each other, how we worship, how we live in society and in community together. In this digital era, we continue to witness the magic of technology, our ability to push forward with innovation, discovery, and growth. And this is driven by what I like to call the superpowers, these foundational technologies that are profoundly shaping how we experience the world. And it creates this bridge from the analog, from the physical to the digital world. It enables us to simulate, to create the digital twin of everything that we do. One of those, compute. And since the 4004, we've just been pushing compute into everything. Connectivity, everyone and everything is becoming connected. Infrastructure with unlimited scale of cloud, but increasingly with edge, unlimited reach for capacity as well as low latency and bandwidth. And AI intelligence everywhere, turning this infinite data into actionable insights. And I've been framing these 4 superpowers for a while, and then in conversation with some industry peers, and in particular a conversation with Thomas Friedman, the Pulitzer Prize winning New York Times author, he convinced me I was missing one. Sensing. And everything that we compute and connect is now becoming increasingly able to sense. We see objects and even be able to see things that you can't see, right? Hear things, know exactly where you are, and increasingly be able to feel, taste, right? All of our senses. And I want an augmented reality where all of my senses become digitally enhanced as well. And even my infirmities, like here's my hearing aid, it's part of our family, right? We lose our hearing, but now, what did she say again? I know more about you than you think I know. Even my disabilities become sensory devices to make my everyday better. Each one of these 5 powerfully, individually, just changing. But as you think about it, more sensing means more compute. More compute means more connectivity. More connectivity, more infrastructure. More data over that infrastructure, more AI, which leads to more use cases, right? They're reinforcing, accelerating, empowering each other to unlock even more powerful possibilities in the future. It also changes how we think about our business as well. And how we think about chip design and the role that we play in this industry. And with that, we launched Intel Foundry Services, a key part of our IDM 2.0 strategy to help meet this growing demand for advanced global semiconductors. And we've committed to a strategy of helping to build a more balanced and resilient supply chain for the world. And at its heart, of course, is Moore's Law. And for decades now, I've been in the debate, is Moore's Law dead? And the answer is no. And with advances in transistors with RibbonFET, advances in power delivery with PowerVia, right? With breakthroughs in lithography, with high-INA lithography, the core of semiconductor manufacturing, with advanced packaging technologies, we aspire from today about 100 billion transistors on a single package. By the end of the decade, 1 trillion transistors. 1 trillion transistors in a single package. And we are on schedule or ahead of schedule on this audacious strategy that we have said 5 nodes in 4 years. It normally takes 2 years for a node. We're going to do 5 in 4 years. Are these Intel folks crazy? No, we are just torridly moving to the future. And our 18A, right, the key one where we'll assert as unquestioned leadership, the PDK 0.3 is in the hands of developers today, and we expect our first test chip taped out against that before the end of the year. We will not rest until the periodic table is exhausted. We will continue to be the stewards of Moore's Law into the future. You got it? Alive and well. But of course, to be a great foundry, you got to be a great wafer foundry. And we're going to continue to work to grow that semiconductor demand, build more capacity, work with our customers as a foundry. And we've announced our intention to acquire Tower Semiconductor. Combined with IFS, we will have a global diverse end-to-end and one of the richest portfolios of differentiated technologies available today as a foundry provider. But our vision is much greater than that. IFS will usher in what we call the systems foundry era. And as the focus moves from system on chip to system in a package, and we see a systems foundry having 4 components to it. First, you got to be a great wafer foundry. We're not debating that. Got to be good at that. But second, right, it has to be great at packaging. And even Gordon Moore, when he wrote his original paper on Moore's Law, he foresaw this day of reckoning where we'll need to build larger systems out of smaller functions, combining heterogeneous and customized solutions. And with 2, 2.5, and 3D stacking, this gives us the ability to increase the number of transistors per device. Third, software. And as you're going to hear from Greg tomorrow, he calls it software, the soul of the machine. And we'll take these stable software interfaces that allow you to accelerate your product development and delivery. Open source software stack, the key software components that unleash the different chiplets, accelerators, and abstractions. And we're increasingly going to make that common through our one API solution. And as we like to say at Intel now, software-defined, silicon-enhanced. Software comes first. And the fourth, a vibrant chiplet ecosystem. And just as Intel has played this pivotal role in standards, like PCIe and Ethernet and Wi-Fi over time, and my granddaughter, when she plugs in a USB stick into the computer, she says, "Thank you, Papa." Yeah. You may like me, but I care more what she has to say. And once again, we're going to lead an ecosystem to create the standardization of a chiplet architecture, and we'll call it the Universal Chiplet Interconnect Ecosystem, or UCIe, and we already have more than 80 companies who are participating in this creation of this open chiplet environment. And you can imagine something like this. Hey, I'm getting a few of my chiplets from Intel, but hey, I have a few of these pieces that I've also developed on TSMC, and maybe my power delivery components are coming from TI, and I have some of my I/O chips that I'm doing on global foundries. Bring those together, and of course, Intel with the most advanced packaging technology, assemble those together for me and be my supply chain manager. So we're going to bring all of those pieces together, enabling what we'd say is this next generation of the chiplet ecosystem. And let's just hear from a few other voices that are joining with us in this vision.
At TSMC, our goal is to provide an open silicon platform to unleash customers' innovation. That's why TSMC fully supports moving the UCIe ecosystem forward.
The future is chiplets. This is why Samsung supports the UCIe goal to establish an ecosystem of chiplets that will drive the next era of heterogeneous computing. Thank you.
So with Intel, Samsung, and TSMC, you've just heard the three largest silicon manufacturing companies committing to a common direction. And as part of our IDM 2.0 strategy, we're committed to investing in the fundamental capabilities to enable this ecosystem, but also the next generation of talent as well. And part of our $1 billion IFS Innovation Fund is directly investing in companies and startups and disruptive technologies. And we've had phenomenal response, even in the early days of forming this ecosystem. We've already made our first investments and many more in the pipeline to come. But we also have this desire to expand the talent much more deeply. And we have our university shuttle program that we've been running with a select set of public and educational institutions to enable them to have modern technology for their classes, training, and talent development. And I've given our team an audacious goal to scale our shuttle program, the passengers, the number of chips that we're doing, 100x. Working with 100x. Did you hear that again? Right, 100x increase in our shuttle capabilities. Professors, researchers, students, all of them being trained on the latest EDA tools and having access to shuttles that they can be sending their chips to manufacturing on the most leading process technologies in the industry. And I think of this just like when I did my first DRAM design and sent it to Moses for manufacturing. 40 years ago, but we want to build that talent pipeline for the future. And we're going to work with these institutions to radically increase the semiconductor talent flow of tomorrow. This is our commitment to the future of the semiconductor industry. Switching gears, another passion of mine has been in this area of graphics and accelerated computing. And we've been delivering integrated graphics for decades. But we've also known for decades that high-density computing, high-performance vector, matrix, the highest bandwidth requires a different solution as well. And this area of HPC has ushered into AI, machine learning, and core graphics technologies like ray tracing. And personally, I've been on this journey for 16 years. When I left Intel 12 years ago, it was the only major not done on my list of things that I wanted to finish. Well, I'm back, and we're now going to get it done. And with that, I'm delighted today to announce our GPUs. We got not one, but three of them to describe today. And the first GPU is our Intel Data Center GPU Flex. And this product, pixels are growing exponentially for a range of workloads, visual cloud tasks, media transcode, cloud gaming, inference and training, and AI. And this is industry's first hardware-based AV1 encoder for a data center GPU, delivering more than 30% bandwidth savings or more streams per platform, however it's monetized by the cloud provider. Open and full stack API access. And today, Flex Series is supporting One API, of course, but enabling frameworks like TensorFlow, OpenVINO, and PyTorch as well, GPU Flex. But of course, the first cousin of big AI and data centers, high-performance computing. And this is our Ponte Vecchio, our flagship high-performance GPU that uses our most advanced IP, really setting the pace for our most advanced packaging technologies, petaflops of performance. And together, Ponte Vecchio, along with our Sapphire Rapids HBM, our 4th generation Xeon, right, is the computing brains behind the Aurora supercomputer. And together we're delivering these blades right now to Argonne National Labs to build the world's highest performance supercomputer. But where did it all begin? You can't talk about GPUs without talking about gaming. And for a long time, we've been seeing that the average price of GPUs is right in this, $200–300 range. But what's happened the last few years? They've just gotten super expensive, and we don't think they need to. Today, we're about to fix that. And we are, with gamers, delivering and hearing the complaints of high prices. So you should be frustrated because you are losing out as the gaming community. And today, we're fixing that. Here is the Arc 770. Right, this is our top-end gaming desktop GPU packed with features, delivers 65% better peak performance in ray tracing versus competition. We've come a long way. Let's take a look at the A770. Yeah, I'm excited too. I'm powering mine up, hopefully this next weekend. And it'll be available October 12th, starting at $329 price point. And the cards are on the way to our reviewers right now. So I hope you're excited. I know I sure am. And you're all here at Innovation because you share my passion. The shared passion to continue to innovate, to continue to use technology as a force for good, to serve the technologists on the front lines, and to use technology to solve today's biggest problems. And we've been around for a little bit over 50 years, and we're the company that put silicon into Silicon Valley. And I remember as a young technician, when I walked into Intel, I was so impressed by the technology leaders that they were there. I thought I had entered the sacred place, going into the temple of technology, where everyone was maniacally focused on what technology could be and how it truly could change the world. And with that, I want to bring on stage a young, bright technologist who embodies that passion to harness technology as a force for good. Ria Cherevue, right, graduated high school at 11, started working at Intel as an intern at 14, the same year she received her undergraduate degree from Harvard. She's a whopping 18 years old today, the same age I was when I started at Intel. And you can imagine, on stage, I am now the underachiever. Please join me in welcoming Ria to stage.
Thank you. It's wonderful to be here today.
Well, thank you, Ria. And like I say, boy, it's not often I feel like I am just like an underachiever starting at 18. Man, you've done incredible things already.
Thank you.
So tell us what you're working on now.
Oh, absolutely. So right now, I'm an AI ethics lead architect. My goal is to develop technologies that help make AI more responsible, trustworthy, and ethical.
Well, you and I have talked about the importance of taking on challenges, and not being afraid to fail. So what do you think?
Absolutely. I mean, I'm ready to take these on head on and solve them. So.
Okay. So, let's talk about this vast community, this vast universe of tools and technologies we're making available to innovators and developers like you, Ria, and how we want to continue to provide easy, affordable access to the latest stuff. And we want to help you get your hands into it without downloads or tough hardware setup. And so to that end, right, and you'll hear more about this in Greg's session tomorrow, right, the Intel Developer Cloud, giving developers access to new and forthcoming hardware solutions for pre-launch development and testing.
Absolutely, and I think my peers are ready to get their hands on this technology and start innovating with it.
Yeah, and we're expanding our Intel Dev Cloud experience. We're not trying to compete with the Amazon, Google, and Azures of the world, but to win your hearts and minds with early access of the latest great technologies that we're working on. And today, the Intel Developer Cloud is limited beta to select and pre-qualified customers, but our objective is to expand that significantly to developers over time for their platforms and to enable the scale of this service in the future.
Absolutely.
And as part of this trial, we're putting the latest and greatest stuff out there. And you'll have access to our latest technologies, 4th gen Intel Xeon, also known as Sapphire Rapids, to Habana Labs Gaudi 2, right, to our advances in IPUs and our NEX technologies. And this is just the beginning, and you'll get updated this week on the full set of things because we want developers to have access to the latest and greatest.
Oh, awesome. And I know that there's a lot of AI developer kits, software kits, reference implementations out there for developers to get their hands on and use right away. So, yeah.
So today, what I want to do here, Ria, if you're okay with this, we're going to set up a handful of challenges, and you're going to help me solve those challenges today. And along this journey, we're going to meet a few other technologists, and we're going to tap into the open ecosystem, choose the right tools, and we're going to use it to build responsible solutions to today's problems. So, you game?
Absolutely. Let's get started.
So, our first challenge, speed up development cycles. And one of the great debates over the history of technology has been this open versus closed, proprietary, protected gardens versus the open marketplace. And since the days of Grove and Gates and Jobs, this has been pervading the industry. And we believe that this idea of the persistent, expensive, closed environments, we are the champion of that open marketplace, and we are back. So John from our demo team is here to help us talk a little bit more about this challenge.
All right, awesome. Great to meet you, John.
Thanks, Pat and Ria. So the challenge is really speeding up development cycles, and I have a tool that I think can help us with that. The Neural Coder, which is a new feature of the Intel Neural Compressor, is a one-click, no-code solution that removes hard-coded CUDA references from our deep learning scripts. It optimizes those scripts for performance, and it benchmarks those optimizations for the best possible deployment options. Let's take a look at how easy this really is. So on the screen, you can see we have an image classification workload running. We're going about 300 frames per second with that. Ria, you want to try the Neural Coder and see what kind of impact it can have?
Absolutely. So all I'm going to do here is go ahead and click the Run button and confirm, and is it that simple?
So that was pretty simple, right? Let's take a look at the Neural Coder output. So the Neural Coder has now optimized our deep learning model from FP32 to Int8. And it's really leveraging the Xeon scalable processor with Intel Advanced Matrix extensions.
That's fantastic. So what's going on with the performance?
Yeah, so let's take a look at the image classification workload again. We're now running at about 3,000 frames per second, which is a 10.8x speed up, really leveraging that built-in acceleration with the Xeon scalable processors.
That's looking good, John.
All right, perfect. So I'm wondering here then, with this type of one-click optimization, everything's good to go and all easy to use.
Yeah,
Perfect.
so maybe we can start talking about security now?
All right.
Well, one of the things is that, security, right, enables the, ability for us, right, to protect our models, to protect our data. And with that, how can we make sure all this model work that we do is actually useful and the data protected around it? So can you solve that problem for us, John?
Yeah, let's take a look at this over here. Let's make security a little bit more simple. So confidential computing with Intel SGX protects your data in use. And here we've downloaded a curated container. And we're going to leverage the Grameen Library OS project, which with a simple script and answering a few prompts, you can protect your data in use. So you want to give this one a shot?
Yeah, absolutely. All right, so this is another one of those one clicks. Going to go ahead and click here and cycle through these defaults.
Answer a few prompts here.
All right. Says it's being created.
Awesome. So all this data that we're using over here, you can now see on the screen that we've protected that data.
Amazing. So this is confidential computing. My container is SGX enabled. I've got protections for my data, and I'm all set when it comes to that.
Great. Optimizations and security.
All right.
So, very good. It's great to see that we're starting to get real traction from the open source community to take advantage of these confidential computing capabilities. And we're working to enable a holistic view of confidential computing. In Project Amber, which we'll talk about tomorrow, a third-party trusted attestation service, which Greg will talk about. So we saw the full pipeline today, right, coming to place, right? What we're doing with AMX as part of our Intel 4th Gen Xeon to accelerate, right, on the CPU as well as on GPUs, the capability, right, making it, complete and protected with SGX, but we're also working on tomorrow with TDX, our trusted domain extensions, which will additionally provide secure enclave at the VM level without requiring application change. So this helps everyone to have more trust in their AI and in their data. So, Ria, I think we've covered, and we can call this one complete in our challenges. Okay. So let's get to our second challenge of the day. So we saw that we can do them faster, but how do we make them more relevant to the marketplace, these AI models that we're doing, and advanced, without requiring an advanced degree in AI modeling? Do you think we can do that?
Absolutely. Let's go for it.
So for this demo, we're going to come over here to this side, and joining us on stage is Giannis from our computer vision and AI team. So, Giannis?
Thank you.
So, today we're going to talk about AI model development. And this is still a very slow and expensive process. Even then, only a fraction of the models make it to production. Why is that? There are several reasons, but the main reason we see is that domain experts are left out of the loop. So when we hand the model over to them, it may have drifted, making it unusable.
Oh, absolutely. I've seen these issues all the time: accuracy drift, poor inferencing quality, and then there's also problems with the outputs of AI systems. And I'd also like to see a lot more collaboration between domain experts and data scientists, really drive those collaborations, get to higher quality models faster. So you have a solution here for me?
I have good news for you.
Okay.
Intel has built an intuitive computer vision platform that enables anyone on enterprise teams to collaborate and build models very efficiently. Let me show you an example. This is the image of a coffee plant, which is behind the $400 billion industry.
Well, coffee's pretty important to me, right? Enough coffee, all things are possible, Giannis.
Yes, and we say developers turn caffeine into code. So, we want to help those coffee farmers to use AI to build models that can predict the maturity of the crop. This way, they can maximize the yield. So let me show you how you can build a computer vision model to do that. So we have this project here, and I have already uploaded some images. So let's go and open it.
All right. So a question here. I can only see a couple of images, but in a typical computer vision workflow, we'd probably need tens of thousands of images for this step.
Well, that's a thing of the past. With this software, we are using a technology called active learning to drastically reduce the amount of training data that the system needs to train. So let me go ahead and open this image here. And I will select one of our annotation tools, and I will draw a bounding box with my stylus around this yellow fruit, which is immature, this orange one, which is semi-mature, and this red one, which is mature. And when I submit those annotations together with some other annotations we did earlier on, the system will start a new training round.
All right, perfect. So what happens after training?
Well, it's going to take a few minutes for the training to complete. So for now, I have already created a project. and I will go and open a previously unseen image. Let's do that. What do you think, Ria?
Okay, this model's doing really well on this image. I am seeing a couple of erroneous and misdetections, though.
You're right. You can improve this model by correcting those misdetections. So would you like to try out?
All right, on the fly. Okay, perfect. So I'm going to start with deleting this little leaf annotation, and then I'm going to go ahead and navigate to the quick selection tool. This one looks over mature, and this one looks mature to me. All right,
You're
I'm
a
done.
coffee farmer already, Ria, or an AI expert. Which is it? I'm not sure.
Probably the AI expert, but yeah, I mean, I definitely need that type of expertise, though, to be able to do this type of labeling, but this is how we can get them in the loop and then make sure that we converge to better models quickly and faster, so right?
Yes, and the most important part is that once your model is trained, it can be optimized with OpenVINO and deployed across different types of hardware at the edge or in your data centers.
Amazing. Pat, I love this technology.
Well, Giannis, thank you for joining us and showing off. This is incredible progress.
Thank you.
Thanks go to the team. Thank you.
And it's a real demonstration of how Intel is building practical, useful ways to deploy AI. And today, we are launching Intel Getty, powerful AI for everyone. And what you've seen here is this new computer vision platform lets anyone in the enterprise teams build computer vision models rapidly. I mean, quite amazing. Big data, oh no, we can do it with small training workloads, and this is now commercially available in Q4 of this year, enabling enterprises to digitally transform and mainstream AI easily into their operations. A true breakthrough. Aren't you excited? Okay, there we go. So now we have how we create the AI models, but of course then our deployment of AI. And this is where OpenVINO has been extremely well accepted by the community and running on this range of Intel hardwares, a fast deployment, creation, deployment to complement Intel Getty. Hundreds of thousands of developers using OpenVINO today. And we have an in-market example to show you here today. Please join me in welcoming VP of Operations of Precitaste, a Vision AI food management platform, Hauke Feddersen. Hauke?
Hey, Ria. Hey, Pat. I hope you're hungry because the next live demonstration will take us into a restaurant.
Ooh, okay.
We help professional kitchen crews by eliminating manual estimation tasks. Our valued customer, Chipotle, focuses on enhancing the customer and the crew experience. Vision AI tells them how much inventory they have at hand and what to cook when to always serve the freshest food and to never stock out. All of this is running on the edge in the restaurant on small form factor edge devices like that one. We chose OpenVINO because other companies' inference-only edge solutions always just focused on the inference and neglected the CPU-intensive workloads that we need to run in the background, like databases.
Okay, that sounds great. So one of the first problems, though, that I'm encountering, and I'm thinking about that you may have experienced as well, is how do you know how much compute you need and whether or not to use the Intel CPU or the GPU?
Great question. OpenVINO opens up a huge variety of devices for us to choose from. When we pick a device, we benchmark it to verify that it has enough performance for this and future use cases, and then we deploy it. Then it's actually the auto-optimization plugin in OpenVINO that makes the decision whether to run our model on the CPU or on the integrated GPU. And the best part is, with each generational upgrade, our customers get so much more performance out of one edge device. The generational jump from Gen 11 to Gen 12 took us one afternoon, and it resulted in 30% more frames per second for our application.
Amazing.
Well, hold that thought. I mean, that's pretty powerful, right? So essentially, OpenVINO allows you to not worry about the underlying hardware, right, and allows you to be, taking, advantage of these capabilities. It's like having a world-class performance engineer standing by your side as you're deploying.
Absolutely. Let's see it in action. In the restaurant, we have those Intel RealSense cameras mounted above the make lines, seeing the food in real time all the time. And we use the OpenVINO to detect the corners of each of those pans for a dynamic region of interest. Then we use OpenVINO to classify the ingredients, to know what we're looking at, and we use the stereo sensing from the RealSense to tell us how much we're looking at.
Right, so that's a lot of models that are in, like, part of a workflow. So how is OpenVINO helping you here with like this much compute?
We're running multiple applications on just very few of these edge devices in the restaurant, from what to cook when, to digital prep, to freshness monitoring, and order accuracy verification. For that, we need tracking performance. And careful quantization, and OpenVINO gave us a speed up of 2x. We're now running live inference from 2 vision streams on just one edge device.
All right, so your performance engineer has a question, or your temporary performance engineer. If we switch around those pans, how are the depth sensors going to react?
Let's do it.
Challenge.
If I take out one pan
All right.
and shuffle them around a bit, we can see that the AI is orienting itself again and knows exactly how much food is available. And if I start serving this delicious salsa, dig in, dig in.
I like salsa.
The inventory depleting, and the crew is being asked to replenish so that the restaurant never stocks out. Chipotle is using this computing one-stop shop to scale their amazing operations. But don't take my word for it. Hear it from Chipotle.
Let's hear it now.
Hey Pat, hey Ria, and everybody at Intel Innovation. By utilizing Intel technology in our Innovation Center and test markets, we've seen a real improvement in operational efficiency. The combination of the full Intel architecture and OpenVINO software has alleviated manual tasks for our crew and given managers the tools they need to make informed, in-the-moment decisions. By deploying Intel's RealSense and OpenVINO technology, we created a powerful and versatile AI solution that addresses our unique needs while connecting the entire infrastructure of the kitchen. We're excited with the results we've seen in our test market and are aiming to fully deploy Intel technologies across Chipotle restaurants in a large market in the coming months. I'd like to thank you all, the true creators and innovators in this space, and hope you have a great show.
Well, thank you to Kurt. My family loves Chipotle, and now it'll even have Intel inside Chipotle, so we can go there more often.
Absolutely, and with this delicious demo, I can say this challenge is complete.
All right.
All right.
So let's move to our next challenge, if you would, game development. So, modern games are complex. They have, interactivity, lifelike graphics, complex characters, story development, immersive experience. And these are big, expensive development and production operations to bring them to market. This is a lot of work to get done. And to talk about that, I've invited on stage today a world-class game developer, Inflection Games, right, who's striving to bring a realistic, immersive gaming environments onto the PC. Please help me in welcoming Sarah Main-Waring to the stage. Sarah?
Hi, good to meet you.
Thank you, Sarah.
Hi, Ria, good to see you.
Thank you.
All right, so I'm from Inflection Games, and we are creating Nightingale, which is an online multiplayer survival crafting game. And when we're working with a multiplayer game that's online, we get networking bugs. And these can really tie up our development schedules when we try and debug them. And whilst we're very good at doing this, sometimes we don't have any shortcuts. So when we are doing our debugging for these issues, we are connecting multiple clients on a single machine in the editor, usually with a test level. And so here's the test level I wanted to show you today.
Oh, that's beautiful. Looks immersive. Am I hearing birds?
There is a little bit of birds coming out, yeah. And so this isn't the usual test level that I would use to debug anything in. This is a real Nightingale player level running in Unreal Engine 5 on this rig. And usually we would be working in a test level that's very small, contained, very empty, so that we can really drill down to what the problem is. But sometimes that's not possible. Sometimes there is a bug or an issue which only shows up in player-facing levels. And then we run into problems because we have to run these very high-fidelity, dense levels directly on our work machines on a game which is only optimized to run one client on one machine at any one time without the editor even attached.
Absolutely.
And so you can see that we've got some pretty good performance going on here. It's really nice and smooth. It's looking real beautiful. On my workstation, back at work, this would be what we would be getting in the editor. But we wouldn't be able to connect more than one, maybe two clients before the frame rate just drops off. But on this wonderful workspace, we've not only got one going, oops, excuse me, give it a little punch there. No problem. Oh, well, sorry, my keyboard is not working.
No problem.
Yeah, no worries. Let's see what I can do. Yep, my keyboard is not working, unfortunately, so I can't tab to, oh. Okay, so we're switching over to some backup images, but we'll see. So we switched over to some images here.
It's real.
It's real, yeah. It's development problems. And so what you can see
I think,
here,
Sarah, we found the bug.
Yeah, we found the bug.
Okay, good.
But what you can see here is that
There we go.
we are running 4 of these instances all at the same time with the same frame rate. And it performs wonderfully. And actually, in back, when I had a bit of downtime, I tried 8. And I was able to run 8 of our game instances, which are only optimized for a single on the client at any one time. And yeah, just really impressive tech.
Absolutely. I think peripherals aside, this is exactly what we're starting to get into. Game development's just going to get better and better. And Sarah, to your point, to highlight a cool feature here, I think hybrid architecture is definitely what developers can use here to make their lives much more easier. You can hide the windows that you don't really need so that your OS and your different platforms and applications are able to take advantage of what they do need in the front view and hide or put away the stuff that you don't. But it's a beautiful test environment, and it's a beautiful use case.
And being able to connect 4, 8, however many we try to do clients at the same time just speeds up our ability to debug and get to these nitty-gritty problems that are only showing up for our players. So it's a big deal for us to use Intel's technology for this.
Absolutely, and definitely as part of that hybrid architecture, performance and efficient cores or P&E cores, that's definitely going to come in handy for these types of tasks.
Yeah, and this is in editor, and we've prepared a little bit of footage to see what Intel technology is giving Nightingale outside of the editor. Can we run the footage?
Let's see it.
We're going to roll it. That's epic. I caught Pat having a jump scare, but I am so excited to be able to play that.
Yeah, we look forward to you all getting to get to try it soon, hopefully.
All right. Thank you, Sarah. This was awesome.
Thank you, Sarah, for joining us. Exciting accomplishment with the game coming out, and can't wait because I know end users love it. Our platforms want to consume it and deliver it, and we're committed to making all this real. Thank you so much, Sarah.
Thank you, Pat. Thank you, Ria.
Thank you.
And as you just saw, the future of gaming and creative, immersive experiences like that relies on performant CPUs and GPUs. And with that, today, I am thrilled to reveal the 13th gen Intel Core desktop processor family. Formerly known as Raptor Lake, the flagship i9-13900K is coming next month. This is the fastest, best desktop processor ever built in history, and it takes advantage of our hybrid architecture, both E and P cores. We've enhanced the P core so it has the best single-threaded performance ever, more L2 and L3 cache. We've also increased the number and improved the E-core capabilities for compute-intensive workloads and workflows. Together, the E and P cores work together in a hybrid architecture to deliver the best multi-threaded performance. It has blazing clock speeds of up to 5.8 gigahertz, and the i3 13900K is the best gaming, streaming, and recording experience ever. But make no mistake, it's the best CPU, but it's also the best platform. And our core processors deliver on the platform value propositions, state-of-the-art wireless, connectivity, advances in memory technology. As always, we are building and leading open platforms with and for the industry. And whether you're a beginner or an expert, the Intel 13th Gen core delivers the world's best overclocking experience as well. And early next year, we'll release a SKU that for the first time ever hits 6 gigahertz out of the box in limited volumes. An industry first, a huge milestone for client computing. And I remember, like it was yesterday, when we first crossed 1 gigahertz. Man, you all are blowing me away. 6 gigahertz, what a milestone. Congratulations to our team. But of course, we're not stopping with the K SKU. We're going to give you the full range of PC segments, including mobile. And we expect over 50 processors as part of the Raptor Lake i9 family, or the 13th Gen family. And we have over 500 13th Gen designs.
I'm back, and I think we should definitely get Hawk at that version.
Yes, I think so. Our game is definitely going to take advantage of this. And given the sheer power and unique hybrid architecture that comes with the 13th Gen processors, I think we can say with confidence the gaming challenge is complete, Rhea.
All right. Thank you.
So let's move into our fourth challenge, and this one's for content creators that need a creative boost.
All right, let's do it.
So I think we need to commemorate our time together today, Rhea. Right. And with that, why don't we do a movie poster?
Okay.
Right? Pat and Rhea's greatest hits kind of poster. And have you ever seen any of the text-to-image creative platforms?
Well, I've definitely seen it. I could even say you're asking the master. I have tried so many different Stable Diffusion models. It's constantly growing, but definitely something that only advanced deep learning enthusiasts can get their hands on. Very hard for content creators to be able to use that technology right away.
Okay, well, AI is unleashing this wide array of new opportunities for the creative process. And John is back on stage to show us some amazing technologies from Habana Labs using Gaudi 2. And maybe we can help create our movie poster, John?
Let's do it. So
right.
You mentioned text-to-image conversion, and we're running a latent diffusion model on our Gaudi 2 deep learning accelerator. Pat, Rhea, you want to start the creative process?
Well, how about movie poster?
All right, I'm doing it. The stakes are high.
So the Gaudi 2 is generating 16 images here in just under 3.5 seconds.
Fantastic.
Okay, well, can we go a little bit further? What do you think, Rhea?
Absolutely. Let's do superhero
Okay.
poster on the fly. Gonna type this out here. Let's see.
Okay, that looks better. Okay.
All right.
So, what do you think? Should we take it a little further?
Yeah, absolutely. Let's do something a little bit more cool.
So maybe, male and female superhero movie?
Yep, absolutely. In the style of Art Deco. And that's going to give us a couple of cool images that the model is trying to generate pretty much real time.
All right. I think we're looking pretty good here, John. What do you think, Rhea?
I think it's great. The speed is phenomenal. It's giving me a lot of inspiration for different ideas that I can use. Definitely some improvements, but, yeah, I think it looks great to me. John, thank you.
Yeah, I can't wait to see designers use this and speed their creativity.
Absolutely.
And, John, I think what we've seen here is the incredible power of the next generation Gaudi processor. And here I have the Gaudi 2 accelerator. This product comfortably outperforms the A100, ResNet 50, BERT models, the June publication this year of the MLPerf benchmarks. And this model we're running is latent diffusion on PyTorch. So what do you think, Ria?
Absolutely. Those words, the machine learning models, they bring joy. So I think this is fun. We're definitely done with this challenge and looking forward to seeing what comes next.
Okay, this challenge complete.
Okay, so I think that was a great challenge, but I'm also encountering a little bit of a difficulty, Pat. So something that I really struggle with is you need a lot of devices in order to be able to do this type of content creation and being able to, train your deep learning models, and those devices don't even talk to each other.
So, I think, Ria, that sounds like a good challenge to me that we can attack this morning.
All right.
And with Centrino, integrated Wi-Fi, we created an industry. And 2-in-1s and convertibles, we've just been driving these unique experiences throughout our history. So we start with people, what do they want, and design solutions for them.
Okay, perfect. So here's what I want. Maybe there's a solution out there for me. I need a solution to having to lug around my very large monitor all the time.
Okay, so, right, making it a lot easier. And, I was in Korea a little while ago, and when I was there with our partner Samsung, they showed me a technology that I think might just solve that problem. And I'm delighted to welcome the CEO of Samsung Display, J.S. Choi, to stage.
Thank you.
So I saw this prototype when I was on a trip to South Korea, and I instantly saw the potential for our platform. And I just wanted to let everybody geek out a bit with JS, Ria, and I. So JS, what do you got here?
Yeah, it's great to be here. So this is a small PC, right? But sometimes we need this bigger screen. So let's see. I'll show you the magic. Whoa.
Okay, my turn.
Okay.
Okay, I gotta play.
Okay.
Whoa!
Okay.
All right, I want to try. Phenomenal.
I'm sure this shows one of the great examples of future trend of PCs. It's because I'm here today to demonstrate this demo. It's very important for Samsung Display to collaborate between ecosystem developers in hardware and software together to achieve this kind of innovative form factor PCs for best user scenarios. So let me have this one. So today we announced world first 17-inch slidable display for PC globally for the first time.
Thank you.
Wow. Yeah, this device will satisfy Ria's need for larger screen and also its portability as well. With flexible display, we implemented sliding technology rather than foldable. Foldable is gone, but it's just beginning, right? So with this slidable flex and software collaborations, we expect to see better and best user scenarios of PC near future.
JS, thank you for joining us here, right? And as the leading provider of OLED technologies, as many decades of partnership, this just convinces me we got a lot more coming between us. Thank you for joining us, JS.
Thank you.
Thank you.
Thank you, Ria.
And I'm assuming I can keep it.
And again, continuing new form factors, we create new SDKs to enable those and find new experiences for our customers and community. And speaking of which, earlier this year at the CES show, we announced our acquisition of Screenovate. And this is now coming forward as Intel Unison. And to show an example of Intel Unison, please join our demo geek, Craig, coming to stage. Craig?
Hello, Ria.
Hello.
How you guys doing today?
Doing great.
So,
I'm here to show you off some amazing things that we're going to be doing with Unison.
Okay.
But for the first item, might as well pair some of this amazing software that we have in Unison, with some of this amazing hardware from Samsung Display. Okay, beautiful. But really, what we're saying with Unison and the promise of Unison is to bring all of our devices together, regardless of ecosystem or how they move and how they interact, all of our smart devices, again, really working for us in the way that we want to. And just like you said, Pat, with Intel, we're trying to solve the world's largest problems. Well, Pat and Ria, I have a lot of problems. So not those type of problems, device problems. So similar, so something like this, I have my great little Evo PC here, and with just a quick, nice little tap, I'm gonna go ahead and send it on over to my display. Oh, let's see here. And here we go. Ooh, and I've extended my display to this nice little 13 to 17-inch device, which helps me with a lot of my problems. I like to have a secondary screen for a lot of road warriors like us, and so I can take a little 13-inch tablet that I have in my backpack and then turn it into a 17-inch monitor. No back problems, no TSA.
So you're telling me that could I connect like my iPhone to the device, or?
Ria, that's exactly what I'm telling you.
All right.
All of your devices. That includes iOS, an Android device like this, all working together for the first time with our Windows PC. So, Ria, your iPhone will be singing and dancing and playing with your Windows PC. Never lose focus. Get all of your notifications, all of your emails, all of your texts, and be able to bring that vision. And that's the dream, right, guys? All of our devices working for us, and we're here to bring that dream to you with Unison.
Amazing. Thank you.
Thank you, Craig.
Thank you, guys.
You know, an Intel Unison is a new software solution promoting this open ecosystem approach, solving Ria's problem, right? You know, but also enabling the iPhone for the first time, interacting seamlessly with the PC, all our iOS, Android devices, and coming with new laptops this holiday season from our partners at Acer, HP, and Lenovo. And this is just the beginning of what we're going to be enabling with Intel Unison. So what do you think, Ria?
Absolutely. It's astonishing technology. You didn't say no when I asked if I could keep it, so I'm making some assumptions. But I would say that this challenge is complete.
All right.
Thank you.
You know, and our final challenge of the morning, sometimes the biggest challenges we face, technologies at the pace of change. And we can invent these innovations, but is the market ready for them? And sometimes the technology isn't ready for the market. And for instance, my passion for silicon photonics. And, you know,
well, our vision is to fully enable our chips with optical capabilities, such that our processors today, a piece of silicon, a piece of optics, fiber, going directly into that. The result of that will be much higher bandwidth, much higher communications capabilities at dramatically lower costs. Today, optics is a niche technology. Tomorrow, it's the mainstream of every chip that we build.
So, that was a video of me 2 decades ago predicting this moment.
Right? And that was the year I was born? So.
Oh, really? You are killing me. You are killing me. And sometimes innovation takes a little bit longer than we want. You know, sometimes a decade to make a week of progress, sometimes a week to make a decade of progress.
Absolutely. I love that quote. And I understand it takes a lot of hard work and talent to make these ideas into reality.
Yeah, and at Intel, we invest for the long term. You know, we know that optics, this dramatic amount of bandwidth, you know, moving from photons to electrons, crossing the optical electrical boundary, this was hard. And bringing light and bandwidth and low power right up to the package, and then scaling it for the industry to participate in it. So here we are, and we can now show this breakthrough. Our engineering team has done it, and they've built a detachable optical in-package connector coming directly into a glass substrate. Let's go live to our lab in Scotland and take a look to show it for the very first time. Russell?
Hi, Pat. Hi, Ria. Welcome innovation to Scotland. So what we're going to do today is, yeah, thanks everybody. So what we have behind us is a test and measurement system where we're going to test that detachable connector. So we have on the left-hand side a power meter. So what you're going to see is the power should flick up to the right-hand side. You'll see the needle in the power meter. On the right-hand side, the signal will go from red to green as we make the connection directly to the package with our detachable connector. So what you can see here with John, we have the demo unit here. We have a silicon photonic package. We have optical fiber that runs up through the connector. It's a very small form factor detachable connector. And we're going to measure the light that comes in and out of the silicon photonics chip with this setup, okay? So, first time we've done this live, obviously, so John's going to make the connection now. Keep an eye on the screen. You'll be able to see the numbers as we make the connection. So here we go. So we got power coming into directly the silicon photonic package. The green signal, that means we're measuring light all the way through the package. But we have to show that it's also detachable. So we're going to detach it, reattach it again, and we'll be able to show that here now live. Okay, John. So there we go, we've detached it, the signal's dropped off, reattaching it, and now the signal's jumping back up again. Okay? So great result, everybody. Thank you.
Hey, Russell and team, thank you so much. This is exactly how I dreamed of it decades ago, and you guys are now delivering it. Thank you. Congratulations to our team in Scotland.
Thank you.
That's great. Thanks.
Can't believe I get to be part of this history-making moment.
Indeed, indeed. So, Ria, thank you for joining me on this journey. In 30 years, when you're on stage as the CEO, remember to continue to pass on the shared passion that we have for the world of technology and the enormous positive tech for good impact that it can have.
Oh, absolutely, Pat. And I think on behalf of developers everywhere, we're ready to get these technologies running, working for our workflows, optimized, accelerated, and changing the world.
So maybe a memento for you. Let's
Right.
sign our poster here that we did.
Okay.
Grab your pen there, and you and I are going to sign it, and we're going to send you off here, right? This first superhero moment,
Okay.
right?
Gonna add a smiley.
All right. There we go. Let's say thank you to Ria for joining us.
Thank you all. Thank you, Pat.
So throughout our time together this morning, we've talked about our commitment to being open, systems and software and hardware standards. And our collective potential as an industry is unleashed when we enable openness, choice, and trust. So to close out, I want to bring on stage a special guest, someone that I have personally admired for decades, a no bigger champion of open collaborative ecosystems, the godfather of the open source movement, the creator of Linux kernel and of Git. Please join me in welcoming none other than Linus Torvalds.
Hi, Pat. Thanks.
Linus, it is so great to have you at Intel Innovation. We've both been around the industry a few years.
Yep.
And you remember this?
I do remember that. I lost my own copy a few years ago, apparently.
Well, today we are fixing that.
Yeah.
I've signed this for you here.
Thanks.
And when I wrote this book, it was the Bible for the 83, 86, and this was really your beginning.
Literally, this was the thing I used on the project that wasn't Linux yet. Before I actually started doing an operating system, I was really just trying to learn about the new PC I'd bought. And this was the CPU side of that journey, right? And it took a while to learn the CPU and realize that what I'm actually writing is an operating system. So this, in a sense, predates my Linux work, but was very integral to it.
Yeah, and maybe you could just take us back to 1991 when you were first getting started on the project, and tell us a little bit about that.
So it's hard to even think back now because It was different for me. I came from a home PC kind of background and did not know the x86 architecture at all, but decided that this was the way into it, and bought my first 386 and couldn't afford the commercial Unixes I wanted.
Ah.
And
So you were cheap.
I was cheap.
Or broke.
No, I prefer the word poor.
Poor, okay.
Right.
Yeah.
And I'd grown up with computers since I was about 11 and was used to just writing my own projects. So the fact that I could not afford Unix myself, and I had this shiny new PC, and I had been exploring the CPU side of it, and because the 386 has the task switching hardware built in, it had been one of the things I'd been exploring. And when you do task switching and do all the low-level grotty paging details that this book literally goes through and explains, you kind of end up with a project that is the beginning of a kernel.
Yeah, looks like an operating system. Yeah. So here we are today. Tell us, what are the must-dos for a thriving open source ecosystem?
I think the must-do, one thing I really strive for is to make sure that people feel like they are part of, I don't want to say the community. I mean, it is part of the community, but they're part of making decisions, and they really own the end result.
Invested in it.
They're invested in it. And it's obviously why I chose the license I chose, making sure that I don't have any special rights. And I really love open source. I love working in a community where it's about open discussion and really getting things done together. And that's actually surprising to me, even now, because I always, and I still feel that I'm not a people person. But at the same time...
I've heard that criticism of you.
Yeah, no, I'm not the only one who thinks I'm not a people person. But at the same time, it's been what has really motivated me for the last 30 plus years.
So let's go forward, 10, 20 years. What's your vision for open source in the future?
Yeah, no, this is not me. I'm not a visionary. I call myself a plodding engineer.
Plodding engineer.
And I say that with pride. I think you need the people who have the big ideas, but you definitely, in engineering, a lot of it is getting all the small details right and looking at in front of your feet instead of looking 20 years out. So I look a couple of releases ahead, and I kind of have a notion of what's coming, but my horizon is about 6 months away, not 20 years away.
Okay, so I'd like to introduce you to Linus Torvalds, my favorite plodding engineer.
Thank you, Pat.
Your career, your impact, the industry that you've affected is nothing short of spectacular, Linus. And I mean, you and I, we're not finished yet. We got a lot of time in front of us yet. But we'll be realizing the impact of your contributions for many, many years to come. And it's with that in mind that today we are honored to give you and recognize you and our community as we come here together, right? We would like to say that you are the first recipient of the first ever Intel Innovation Award.
Well, thank you, Pat. I don't know what to say. That is actually very nice and classy. We had a water bottle as a stand-in yesterday during the rehearsal.
This was a little nicer, right? Yeah.
Which wasn't so nice and classy.
And while I was absolutely thrilled to have this conversation with Linus and I this morning, we recorded a long interview yesterday. We'll be posting that on our website. And truly, I couldn't think of a more honoring person for an open community than Linus Torvalds. Thank you so much for joining us today.
Thank you, Pat. Thank you.
We've had an incredible morning together. but this is just the beginning. We're just getting started. In the next 2 days, labs, demos, show floor, cool, geeky things that we're going to do. I encourage you to sign up for the Developer Cloud, download our One API toolkit, and engage with us, because our objective here is that developers, whether software or hardware, you see the future, and our job at Intel is to open that future up to you, working together on open frameworks that you can trust. I'm excited we've had the opportunity to come together to learn, grow, build, challenge, and help each other. And together, we've taken a peek into the future, one that we will create together. Thank you.